A sequence converges to a finite number L if the limit as n goes to infinity of the sequence equals L. Keep that picture in mind. The terms themselves have to settle down on one fixed value. The series is built from that same sequence, but we look at its partial sums. Add the first term, then the first two, then the first three, and so on. The series converges to S if the limit of those partial sums equals S. One special case is the geometric series, the sum from n equals 0 to infinity of a times r to the n. This converges to a divided by, open bracket, 1 minus r, close bracket, whenever the magnitude of r is less than 1. If the magnitude of r is 1 or more, it diverges. There's also the nth-term test for divergence. If the limit of the terms does not equal 0, the series must diverge. But be careful, the converse is false. Terms shrinking to 0 never guarantees convergence. It only fails to rule divergence out. Now let's work an example. We want to determine whether the sum from n equals 1 to infinity of 3 divided by 2 to the n converges, and if so, find its sum. First, rewrite the general term. 3 divided by 2 to the n is the same as 3 times, open bracket, 1 divided by 2, close bracket, to the n. So this is a geometric series. Since the sum starts at n equals 1, not n equals 0, the first term is 3 times 1/2, which is 3 over 2. The common ratio is 1 over 2. Check the ratio size. The magnitude of 1 over 2 is less than 1, so by the geometric series rule, this series does converge. Now apply the geometric series formula. Sum equals a divided by, open bracket, 1 minus r, close bracket. That's 3 over 2 divided by, open bracket, 1 minus 1 over 2, close bracket. The bracket 1 minus 1 over 2 simplifies to 1 over 2. So we have 3 over 2 divided by 1 over 2. Dividing by 1/2 is the same as multiplying by 2, so the 2's cancel and we're left with exactly 3. The series converges to 3. Here's a trick for spotting a geometric series quickly. Take the ratio of consecutive terms, that is, term n plus 1 divided by term n. If that ratio simplifies to the same fixed number, no matter which term you pick, the series is geometric with that number as its ratio. Now, a common trip-up, learners often apply the nth-term test backwards. They see the term shrinking towards 0, like our 3 over 2 to the n did, and wrongly conclude the series must converge, but shrinking terms alone prove nothing. Remember, the nth-term test only ever proves divergence, never convergence. Plenty of series have terms going to 0 and still diverge, so seeing terms shrink is not evidence of convergence on its own. So here's the teaching tip. Say the one-directional rule out loud and keep it visible. Terms approaching 0 tells you nothing about convergence, but terms failing to approach 0 tells you the series diverges, full stop. Treat this test as a one-way door that only ever opens toward diverges.